Okay, so what is this mathematical induction we're talking about? Well, we've done in parts in geometry and other parts of mathematics a deductive proof, which basically is going on that you're going to prove something using ideas that you already know about. So, and you're going to use all those and put them in a sequential order and get them into a nice form that you've proved a new statement. This one's a little bit different. Okay, we haven't got those nice background proofs and statements that are true to work with. So what we want to do is prove that you've got a statement that would be true. So whether a series is equal to a given sum formula or whatever we've got, we want to prove that that's true. So what we do, the process we do is, the first part is, the idea is that we want to prove that it's true for any whole number n, and usually it's a positive whole number. Sometimes it might be a negative. It's a bit of a rare type situation, but it can be. We can do that as well. The first one, the idea is that we prove that our statement that we've got holds true for some number, and usually we start with 1 because that's the simplest one. So we start with the number 1 and put that in and show that yes, the statement does work for a number. Now that's not proving anything, just showing that something works. That's okay. It shows it works for a certain number, but you've got to be able to prove it using algebra for every number. So the next part is to say, okay, well, if the statement holds for some number k. Now this is a little bit different than what we've ever done in mathematics. We're going to assume. We're making an assumption. Now we know we've always gone about in mathematics and we never assume anything, because we don't like to make assumptions in mathematics. But we are going to make an assumption in this case. So we're going to assume our statement holds for the number k. What we want to do then is prove. Okay, so we're still going to do some proof. If the statement's true for some number k, and prove that it holds for some number k plus 1. So the next number. So once we've done that, once we've made that assumption and now proved it's true for the next number, we go back to the idea is basically that because it was true for 1, and so some number could have been 1, and then it holds for the next number k plus 1, it would be true for 2. And then if it's true for 2, that we just said, it must be true for 3, if it's true for 3, and then it goes on and on and on. So we can basically, we're inducing a proof that's true for any number, because it's true for the first number, then the second number, and then the third number, and so on. To put it another way, this is another outline. So the basis here, as it says, we start with the smallest integer for which the statement holds, and if strong in induction, more than one base may be needed, so we might need to do a couple of numbers. We have a clear and an explicit statement of what we assume. So assume this statement is true for k, and then prove that it's true for the next one, true for k plus 1. Or if we want to use some notation like that, we can do that. And then the technical part of the proof is we do that proof. So that's where the main work's going to go in, and that's where we're going to do all our algebra, is in that proof. So all the types of algebra we've just been doing, that's where it's going to be working with. And then we conclude. Then you get a sentence summary of what have we established. That's what we say. Like, it's true for 1, because it was true for, we proved it was true for 1, and we said it was true for the next number k plus 1. So it must be true for 2, because it's true for 2, it's true for 3, and so on. That's pretty much the same statement as we make all the time. So that's what we're looking at when we're looking at an induction proof. So those steps, and when we go through the questions that I've set out for you, and if you looked through the notes already, you see that I tried to set it out and get you to follow that same proof statements every time. So we get that same working happening all the time, that we don't go and miss out on the stage and get anything wrong. Okay, so the next video we'll start to go into some of those. We'll use all these ideas, and then we go and in actual questions and proofs.